Okay, so today we will discuss an example in which the reaction rate will be decreased due to the formation of an intermediate which is essentially anti-aromatic in character. There are many examples, but I will discuss only one famous example, which is the bromine addition reaction of alkynes and alkenes. Both alkynes and alkenes undergo bromine addition reaction in order to generate the disubstituted bromine addition products, but the reaction rate for the bromine addition into alkenes is much more faster than that of the bromination into the alkyne systems. So what is the reason? The reason is obviously the formation of an anti-aromatic intermediate in case of the bromine addition into alkyne system. So as we all know, the bromine addition towards the double bond proceeds via this pathway. In the first step, the bromine acts as the electrophile and the double bond attacks the bromine molecule in order to generate this three-membered cyclobromonium intermediate, and then the bromide acts as an nucleophile and opens this three-membered ring in order to generate this dibromo substituted product. You can clearly see that in this case there is no possibility of any kind of anti-aromaticity, but in case of alkynes, after the attack by the electrophilic bromine molecule, the formation of this three-membered cyclobromonium ion takes place, and now we can see that in this three-membered ring there is a double bond and which contains 2 pi electrons, and the one lone pair of the bromine molecule combines with it to generate a system which contains 4 n electrons, in which n equals to 1. 2 electrons from a lone pair, 2 pi electrons from a double bond. So this will be extremely unstable, and to overcome this instability, this intermediate should break down into this acyclic intermediate, in which the positive charge will be now situated over a sp2 hybridized orbital, which is now also also unstable to the same extent. So we can clearly see that due to the instability of these intermediates, the activation energy for this reaction will be much higher, and the overall reaction rate will become very, very slow. So that's it. This is a fine example of the involvement of anti-aromatic intermediates in organic reactions.